So what's really going to happen today is that I'm going to learn, and we all together going to learn something very important, which is moving average calculation using Python. But before that, we really need to understand the fundamental of the moving average. And for that, we'll first go into our whiteboard and we'll understand the fundamentals behind this moving average, right? And then you're going to come to the screen and code it in the Python. The fundamentals is basically we move one step or two steps every time to see, like what is our moving average is gonna be. So thing is, let's say where we have a window for the moving average is the window size of our moving average is gonna be 3, right? Let's assume that window size is gonna be 3 for the moving average, and then we have like something we call it, let's say an array. We have an array. The size of the array, we can define it here: 1, 2, 3, 4, 5, 6, 7. The length of our array is going to be 7, right? So what is really happening when you're doing a moving average is where initially we start with no step skipping. So we're not skipping any step. Initially, this is going to be our window, the subset. And we're going to sum it up, sum this whole thing up, sum it up, the whole thing, and then you're going to divide it by n. I'm going to divide the whole thing by n. And here n is our 3, all right, because the window size is 3. So you're going to divide it by 3. So, but the thing is, it's a moving average, so it would be moving to the right with this consideration of the 3 steps in mind. So next time we'll be moving one step to the right, to the right, and this time as we're moving one step to the right, it's gonna be something we call like the next step, but this is why we call it moving step. And we do the same with this subset. When we move to the next right subset, we do the same calculations on it. So, and again on the step 3 we move one step even further, right? So we move first, we had no step skipping. The second we skipped one step, and on like on the third now we're skipping 2 steps. We're skipping 2 steps and we're taking the subsets of the next right steps. So this is how the moving average really works. The thing is, we can consider each step when to be I, and on each step we're moving one step further. So that's why we can say, like, initially when we start our thing or the calculation, we can consider I to be 0 because we're not moving any further. We're just starting, right? So we take the first one as well, and then from the left we start skipping, right? So once we calculate the mean of the first set of 3, and then we move one step and we consider the next right set of 3. So for that we need to come back and increase. Every time we try to move, we need to come back and increase I by 1, right? So the step, we will increase the skipping points by 1. So the I represents our skipping points at each step. It is our skipping point at each step. So hope this explains the fundamentals that we'll be using in calculating our moving average on pandas or on Python first. All right. So let's call it the moving average dot IPyNB. I'm opening my notebook, selecting my kernel. It's gonna be the environment that I created. All right. So first of all, we are going to look at the function called import pandas. Why? We'll see why we need pandas down the line. We're gonna need it down the line because our result is gonna convert it into pandas data frame. So to be able to convert our predictions into the pandas data frame, we will be using this data frame library, which is pandas, and I'm going to import it as PD, which is what we all do. And let's say we have this list we want to predict. Let's say we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, so let's add a space before each and every point. Data point, these are our data point. All right, we have the data point, and now we need to find out the window size. So how are we going to calculate it? Window size is the set, the size of the set that we first consider to move forward and do the average. Let's say we're going to take last 3 months or last 3 weeks of average, right? So or we can then the window size is going to be 3, and if we're going to take the last 5 weeks of average, then the window size is going to be 5. So we will start and we'll consider the last 3. All right, so we'll consider the last 3. Therefore, we're going to keep the window size to limited to 3. Window size, we're going to limit it to 3. So we have the window size, and now if we remember, we already talked about the the step. So initially we're going to start with the default step skipping, which means we're not going to skip any step, which is going to be 0. So initially when you start, we're not going to skip any step, right? But later on down the line, when you create the function, you're going to mention that every time we do this iteration, we come back and increase it by 1. So this is something we're going to do after we have started the functions, or we can go right into the calculations. We haven't gone right into the calculations. We will be slowly going there. Before that, we need to create another basket. If you remember from the last tutorial, we created sort of like a variable holder, which is a basket where we bring in and keep the new data of the calculations, or the result of the iteration. This is where we keep it. So we're going to create the moving underscore average. This is where our predicted value is going to remain or stay. This is where a predicted value is going to stay, and it is going to be a list because we are dealing with the predictions of the list. So we're going to predict the values of the list based on the historical values, right? In our case, the size of the historical value is going to be 3, because every time we take 3 values, last 3 values, and then we do the mean of it, we sum it, then do the mean of it. So this is how we move forward. But when we do the prediction, we need a place where we want to be able to store our predicted value, that average, the result of the average. We want to be able to store it somewhere. And our moving average is actually that place where we're storing our result of the average. All right. So now, okay, let me bring the A here. So what we have is we have one list which we're going to predict the value based on. We have the window size, the subset of our calculations, and then we have an empty list where we're going to store our results, and then we have our I, where we're going to have our like steps recorded. So it's going to keep track of our steps we have gone or iterated in the program. So now let's write our main program. So it's going to be while I is going to be greater or equal to, sorry, smaller or equal to, while I is smaller or equal to the length of our array. I'm going to explain it, minus window size. Thing is, to be able to iterate through it properly, we have to have our I, the number of already taken steps, have to be below than the window size. So program will only run as long as our I, the steps, is below than the window size. Let's say our step is more than the window size, we'll end up with no value at the end, right? So let's say we're left with 4 data, but our window size is what? 5. Then how are we going to come to a conclusion? How our program will print an error, right? So the idea is to have more steps left, or like, yeah, so I has to be smaller so that we have enough data to iterate through. So I is going to keep a track of our steps already taken. We'll understand it as we move forward in the program. We'll understand it even better. But the idea is that our I has to be lower than the window size. I has to be lower than the difference between the length and the window size. We want to, whenever the length is higher than the window size, only then we can proceed. If the length is more than the window size, or like the I is like less than the result here, like the length and the window size. If it is less, then we can't really do it. So if it is, as long as it's equal to or below, we can run the program. So now what we're going to do is we're going to create the function where we're going to store, let's call it average. This is where our result is going to be stored, right? This is the place. This is the place where we temporarily will store the result of this each and every iteration. So you say, for like, we're going into the iteration, and then we're storing. While loop helps us to go into the iteration. So we're going into the iteration, and we went into the iteration, and when we have the iteration running for each and every considerate value, meaning that for each and every window, we calculate the function, we store it here. The temporarily we store the value here, and then we put the value in the average, moving average. We create the value, and then we take the value, put the value into the moving average. So how we do it? Thing is, we have the sum. We have to have the sum. Sum of what? Sum of the first 3 values, right? First 3 values. We need the sum of the first 3 values. So let's say we have an array, and we take the first 3 values. So we start from I. This is like, if you know how to slice a list, this is where it is going to be really, really handy. So we're going to slicing through the list where we have I, and then we're going to add the window size to our I plus window size. We're going to add the window size to our I. What does it really do? Okay, let me show you what it really does. Okay, yeah, let me show you what it really does. Let's say you want to print. Let's say our I is 0. I is the number of the iterations. So let's say our I is 0, which means our place is 0. So what is really happening, let's say when we are calculating this set, over here our I is 1, right? So we start from where? We start from 1. Because in the first step, our step number was 0. In the second step, our step number is 0. Our step number is 1 because it increases by 1. We will increase the step number by 1 here, but it increases by 1. So when the step number increases by 1, we get a new subset. And in this subset, we need to calculate the 3 next values after 1. So the 1 is also is going to be the place, the position, right? So it can also denote the position. So once we have the position denoted, what we can do is we can calculate the next 3 positions easily. So this is what we're doing. We're calculating the next 3 positions here. So once we have the next 3 positions, we sum it up and we can easily then divide it to find out the average. So to be able to divide it, we can just simply write the window size, which is our 3, right? So window size is gonna be 3. So now we have the average. We already have the average and we can put the average inside. So we can put this average value inside a moving average. So what we're going to do is the moving average dot append and the average. So what we're doing is simply append means take in, add, so to the existing values. So what we're doing is we're appending to this empty list this value. So then we're going to increase the I 1. We're going to increase the I by 1. So increasing the value of I by 1. So what's really happening here, if you look and we concentrate in this code, we first come considering there is zero value, the step is 0 because we're skipping 0 point, right? This is the skipping point, we're skipping 0 points. So we start from the very first point, meaning we start from the position 0. We start from the position 0, we iterate through it, and we take 3 values. And how do we take 3 values? We take 3 values here, right? Take 3 values. We take the first and then the 3 values and we divide it by n. We get our average, and then I put it inside the append, which brings the value inside the moving average list. And then next time we increase the I again. And this time, if we come back here again, we're going to see if the I is still smaller than the window average, than the value that you get from the length. We calculate the length and then we calculate the size of the window. And if the result is smaller or equal to, if the result is smaller or equal to 1 or the I, then we proceed. The I has, the result has to be larger. I has to be smaller. I made a blunder. Yes, I have to correct myself, which is I has to be smaller than the value of the length minus the window size, because window size is the size that we have to consider first, right? And then we have to calculate the value of the length, right? So we have to calculate the value of the length. And when we calculate the value of the length, we divide the window size from the length and we get a value. And this has to be equal to or greater than I, and only then the iteration can take place. Otherwise, the iteration will stop there, right? So once we do this, we can simply now print moving average. See, we have the value. Yes, we have the value here. So let's see if we can shift it or not by, it shouldn't be, no, it doesn't work because it is a function of pandas, and that is why we need to convert it into a pandas data frame. So it is predicting the value, fourth value, because we take the first 3 values and then we predict the fourth value. So fourth value it is predicting to be 2, but in our calculation the fourth value is 4. So there is an MSE, the mean squared error of how much? 2. So if we divide 2 minus 4, we get 2. The MSE is going to be 2. So then this is how we can, like that's the next video where we will be coming up with a program or a function which would use to calculate the MSE or mean squared error. But for this program, we'll move forward to create a pandas data frame. Now, I hope we understand how and why this program, this line of code is important. I hope you really understand that, because this is the building block of this code, of this program, First of all, we take the number, which is the number of the steps, and we see whether it's smaller than the sum of, or the smaller than the length of the array minus the window size. Let's say it's higher. The length and the window size, the difference is higher. Can we do anything? Not really. We can't really, move forward. So now let's calculate, let's turn this into a pandas data frame. So this is what we're going to do, is we're going to write while, again a while loop, length of array. But thing is, we need to create another array. We can't really mess up with this array, because this is our fundamental array. So we want to create another array here. A copy of this array, let's copy it here. We're going to copy the existing array, because we don't really mess up with the existing array. That is our data, and we don't really touch the data. We're going to copy the data, which we really did, and then we want to find out the length of the array. If the length of the array and the length of the moving average is not equal, go into this loop where we try to make both of them equal, right? The length of the array and the length of the moving average, we want them to be equal, because for pandas data frame, you need all the arrays to be equal, right? So we want these two arrays to be equal in size, in length. So what we're doing is, if, let's say, if the length, let's say if the length of array length, this is going to be length, yes, if the length of the length is smaller than the length of the moving average, if the length of the length is smaller than the moving average, length of the moving average, what do you do? We append values to length, right? And then that append, what do we append? We append 0. Append 0. And if it's the opposite, right? So if the length of the moving average is smaller than length of the length, what do? We increase the moving average. So we take the moving average, append at the end, we increase the moving average by 0. Else, we do nothing, pass it. And now, both of the arrays are equal, right? Now that now both of our arrays are equal, what we can do is we can create data frame. Dot. We will be creating a data frame where we want our first column to be data, and then we want our array to sit here, and then we have our moving average. Let's call it for predicted value. We need to make it a string. These are the column names. We're naming the columns. So we already know that pandas data frame can convert dictionaries into a data frame. So that's why we need a dictionary, and we're going to define the name of our column, the name of our data that we're given. We're going to call it like data. The array is now going to be renamed as data, and the value, the moving average, is now going to be renamed as sampred, and then we're gonna give the moving average here. And now index, and what is gonna be index? Let's keep it none. We don't want an index. So our df is created, but then again we want to create another column where we're gonna lag. We're gonna move forward the existing moving average data by 3 steps, which is the window, right? By our window size, we're gonna skip it. We're gonna shift. We're gonna, like, let's say it starts from 1 to 3, but we're gonna start it from the third position. We're gonna shift. We're gonna bring the arrow down. So how are you going to bring the arrow down? We create another column. So let's call it final underscore column, the result, and we're going to take. So what we're going to do is we're going to take the moving average, like the moving average, which is our here df dot sampred. Yes, sampred, and we're going to shift it by our window size. By our window size, we're going to shift it down by our window size. And now if we print the df, see, our data is ready. Our data frame, we have finally successfully created the data frame, and if we look into this, the predicted value comes here. So what we did was we lagged this column by 3 because we're taking the first 3 to predict the next outcome, right? So this is what we really did. We predicted the next outcome. We took the first 3 and we predicted the next outcome. And it's very simple. The only fundamental things we really need to understand is how we're iterating over here at the while and why we're subtracting the window size from the length. I would repeat myself again here. This is very fundamental concept. We want to see I to be smaller. Why? Otherwise we won't be able to work with data because there won't be any data left. If we keep on iterating, we will be like, there a time come when we are just taking the average of 2 value or 1 value, or at one point it will just fail because the program will say, okay, no data found to iterate through, right? So we want to make sure that our steps always considers some data is left, otherwise it doesn't move forward. So with this consideration in mind, we're going to create the length. We're going to take the length, we're going to subtract the window size from the length, and if it is still greater than the I, then we move forward, otherwise we don't. So hope this explains the whole phenomena of this moving average. So thanks.